Welcome to Truth, Trust, and Multimodality, the latest in computational linguistics, presented by AI Frontiers. In this episode, breakthroughs from 39 recent research papers will be explored, focusing on language models, reasoning, safety, and multimodality. Insights are provided for researchers, students, and anyone with curiosity about language AI. The episode features the paper of the day, Wu et al.'s Reason KE++. And charts a journey through the newest frontiers in AI language technology. Can you trust your AI assistant? Large language models sometimes invent facts with remarkable confidence, a phenomenon known as hallucination. Efforts to make these systems safer can introduce new complexities, such as a tendency to favor longer, seemingly more helpful responses. Imagine interacting with an AI assistant that provides convincing but fabricated information. Ensuring truthful outputs from AI is a central concern. Today's research directly addresses these unsettling challenges, asking how artificial intelligence can be guided to consistently tell the truth. Computational linguistics lies at the core of AI-human communication. This field bridges the gap between natural language and machine logic, enabling technologies such as digital assistants, automated translation, and content moderation. The 39 research papers highlighted today represent significant progress in both understanding and generating language. This episode will examine key challenges, innovative solutions, and future directions, focusing on issues of trust, truthfulness, and the global applicability of language technologies. To understand computational linguistics, consider the analogy of city planning. Human language resembles a vast metropolis, while AI acts as the city planner, designing pathways for messages to travel efficiently and safely. The field sits at the intersection of linguistics and computer science, empowering machines to understand, generate, and moderate language. The ultimate goal is to develop AI systems capable of navigating the complexities of global, multimodal communication. Much like a city planner ensures smooth movement across diverse neighborhoods. The first major theme is aligning AI with human values. This involves teaching language models not only to produce correct answers, but also to display transparent reasoning, as demonstrated in the work by Wu and colleagues and Li and colleagues. guardrails, introduced by Li et al., acts as a conversational guardrail, detecting potentially harmful prompts before escalation. Wu et al. Advocate for process-level rewards, aligning AI reasoning with human logic, akin to grading every step in a student's solution, rather than only the final answer. A key technical tool in this area is reinforcement learning from human feedback, or RLHF. The second theme concerns robustness and generalization. Language models often struggle with paraphrased inputs and low-resource languages, as demonstrated in studies by Moore et al. And Varsha et al. Additional research by Hergert et al. Exposes brittleness in set membership reasoning, a task that humans find trivial. Persistent gaps exist for languages like Tamil and other underrepresented linguistic communities. This can be likened to a translator who is fluent in many languages but stumbles when interpreting jokes or metaphors. The underlying technical concept is generalization, referring to a model's ability to adapt to new and diverse inputs. The third theme focuses on retrieval, memory, and multimodality in AI. Zhang et al. Present Tatarag, which constructs task-specific knowledge graphs for more targeted information retrieval. Cruz et al. Introduce adaptive focus memory, allowing models to selectively recall relevant information during extended dialogues. Li et al.'s Uni-MOE 2.0 Omni model unifies processing of text, speech, and images within a single architecture. Yang et al.'s MNWOZ project builds agents capable of both conversation and visual understanding. These advances rely on mixture of experts architectures, functioning like a team of specialists, each tailored for particular tasks or modalities. Several key findings emerge from the frontier of research. Wu and colleagues demonstrate that rewarding reasoning steps rather than just final answers enhances model trustworthiness. Hong et al. Reveal that even small models can undergo abrupt improvements in capability. Gupta et al. Show that hallucinations can be detected by identifying internal contradictions without needing external databases. Li et al. Find that carefully balanced multimodal models can rival larger, closed-source systems. Wang et al. Uncover that current reward models frequently fail to capture the full spectrum of human preferences, highlighting the complexity of aligning AI with nuanced human values. The featured paper of the day is Wu et al.'s Reason KE++. This work directly addresses the faithfulness gap in language model reasoning, where models may reach correct answers through flawed or opaque logic. Reason KE++ combines supervised fine-tuning with reinforcement learning, introducing stepwise rewards that grade each reasoning stage. This approach is analogous to evaluating every line in a student's mathematical proof, not just the final result. The central motivation is to foster trust in both the answer and the underlying reasoning process. Wu et al. Reason KE++ employ stage-aware rewards, evaluating the model at each step of its reasoning chain. The framework is tested on the mQuake-CF3K benchmark, a challenging dataset for logical reasoning. The result is a substantial accuracy gain, reaching 95.48% and outperforming prior methods. Ablation studies confirm that process-level feedback enhances robustness and reduces hallucinations. The overarching objective is to develop AI systems with logic that is both inspectable and trustworthy. The significance of Wu et al.'s Reason KE++ extends to high-stakes domains such as medicine, law, and education, where transparent reasoning is critical. By judging models based on their logical process rather than solely on outcomes, the approach reduces reliance on shortcut learning and opaque, black box behaviors. This work lays the foundation for the development of process-aligned, transparent AI and serves as inspiration for future research into trustworthy language models. Looking to the future, the field of computational linguistics is likened to mapping an uncharted wilderness. Researchers, like explorers, venture into the unknown, seeking new methods for handling low-resource languages and rare dialects. Ongoing work focuses on developing richer evaluation frameworks and fostering collaborative efforts to ensure AI safety. The aspiration is to build AI that can converse, perceive, and reason across diverse contexts, steadily increasing trust through transparent, stepwise advancements. In conclusion, computational linguistics is a driving force for both progress and responsibility in artificial intelligence. The latest research addresses core challenges in reasoning, robustness, and fairness. Wu et al. And other researchers exemplify the movement toward transparent and trustworthy AI systems. Listeners are encouraged to explore the original papers, contribute insights, and join the broader dialogue. The future of language technology is a collective endeavor shaped by all who engage with it. This presentation was synthesized using GPT-4.1 by OpenAI for content generation. Text-to-speech synthesis utilized OpenAI's tools, and visual concepts were provided by Google Tools. A human expert reviewed the content for clarity and accuracy. References for all discussed papers are available in the provided source list. Please note that despite careful review, some oversights may remain. Subscribe to stay updated with the latest in AI research and insights. Join the AI Frontiers community to explore the future of language technology together. Thank you for your attention and engagement. Share your thoughts and questions in the comments below. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.